The APM 2.8 flight controller is like the brain of your drone. It's a small circuit board that tells your drone how to fly. Without it, your drone would just be a bunch of motors and propellers. The APM 2.8 takes information from sensors and the pilot and uses it to control the speed of each motor. This is what allows your drone to fly smoothly, hover in place, and perform amazing maneuvers. The APM 2.8 is a powerful tool for drone enthusiasts of all skill levels. Beginners can use it to learn the basics of drone flight, while experienced pilots can use it to push the limits of what's possible. It is compatible with a wide range of drones, making it a versatile choice for any drone enthusiast. The APM 2.8 is a powerful and versatile flight controller that can take your drone flying to the next level. The APM 2.8 uses a variety of sensors to understand its environment. It has a gyroscope to measure rotation, an accelerometer to measure acceleration, and a barometer to measure altitude. Some versions of the APM 2.8 even have a magnetometer to measure the Earth's magnetic field. This allows the drone to know its orientation and position, even when it's dark or there's no GPS signal. These sensors are constantly collecting data about the drone's surroundings. This data is then sent to the flight controller for processing. The flight controller uses this information to make decisions about how to control the drone's motors. Imagine you're standing on a skateboard with your eyes closed. You'd have a hard time keeping your balance. But if you open your eyes and use your senses, you can easily stay upright. That's what the APM 2.8-S sensors allow the drone to do. The APM 2.8 flight controller is constantly bombarded with information from its sensors. This data is in the form of electrical signals that the flight controller needs to understand. The flight controller has a built-in computer that processes this data and converts it into a format that it can use. Think of it like translating a foreign language. The flight controller uses this translated data to figure out things like how fast the drone is going, how high it is, and which direction it's facing. It then uses this information to send commands to the electronic speed controllers, or ESCs. Once the data is processed, the flight controller can use it to make decisions about how to control the drone. It's like reading a map and using it to figure out which way to go. One of the most important things the APM 2.8 does is keep your drone stable in the air. It does this using a system called PID control. PID stands for proportional, integral, and derivative. It's a fancy way of saying that the flight controller looks at the difference between where the drone is and where it wants to be, and then adjusts the motors accordingly. Imagine you're trying to balance a broom on your finger. If the broom starts to tip forward, you move your finger forward to compensate. If the broom starts to tip backward, you move your finger backward. The PID control algorithm works in a similar way. The APM 2.8 is constantly making small adjustments to the motors to keep the drone flying smoothly. This is what allows the drone to hover in place and resist gusts of wind.